Okay, this is for Algebra 2, and this is the review for matrices. I'm going to kind of ease into it with number 1 and 2. It just wants the dimensions of each matrix. Remember that when you are doing dimensions, that you're going to do it rows by column. So I have 2 rows by 1, 2, 3 columns. There's your dimensions. That's all there is to it. We only have 1 row. We have 2 columns. That one is a 1 by 2. For the next part, I want you to solve each equation. Remember that when there's an equal sign between the matrices, you take the corresponding elements and you simply set them equal to each other. So 7x is equal to negative 14, and 14 is equal to 2y. So if you divide by 7, you get x is equal to negative 2. And if you divide by 2, you get 7 is equal to y. So that's your answer. A little more work on this one. You're going to have 4x minus 1 is equal to 3x. You're going to have 9y plus 5 is equal to y minus 3. Take each of these and get x by itself. You can either move things around, you can put it at y1 and y2. It's not that important how you do it as long as you understand how to set it up and how to solve. So I would move my 3x and I would get x is equal to 1. I would move my y and I would get 8y is equal to, move my 5, negative 8, and so y is equal to negative 1. Once again, you could use second calc 5. Okay, perform the indicated matrix operation. If the matrix does not exist, write impossible. Be careful here. You got to look and see, am I adding, subtracting, multiplying, or dividing? I'm adding, so all I have to do here is combine the corresponding elements. 5 plus 9 is 14. Negative 1 plus 9 is 8. 2 plus 2 is 4. 1 plus 4 is 5. 8 plus 6 is 14. And negative 6 plus 4 is negative 2. And that is your answer. The next one is subtracting, so you're simply going to subtract your corresponding elements. You could do leave change opposite if you wanted to. 8 minus 0 is 8. 3 minus a negative 7 is going to be 10. You might want to use your calculator when you start having double signs there. Negative 1 minus 6 is negative 7, and negative 1 minus 2 is negative 3. Should be a negative sign there. That should not be a decimal there. Okay, so now on the next one, we have numbers in front of the matrices, so we're going to have to distribute first. So this becomes negative 20, 30, 50, 5, negative 5, and 5. Plus, this one becomes 12, 10, negative 6, negative 4, 2, and 0. Then you're going to take those and combine your corresponding elements. So negative 20 plus 12 is negative 8. 30 plus 10 is 40. 50 plus negative 6 is 44. 5 plus negative 4 is 1. Negative 5 plus 2 is negative 3. And 5 plus 0 is 5. So you have negative 8, 40, 44, 1, negative 3, and 5 for your answer. So then you look at this and you would add your corresponding elements. However, this is a row, this is a column. They are not the same, so you can't do it. Moving to the next page. We are multiplying. Remember, you have to check and make sure that you can multiply first. We have a 2 by 2. We have another 2 by 2, so yes, you can do it, and it's going to be a 2 by 2. So you're going to say 5 times 2 plus 6 times 3. 5 times negative 5 plus 6 times 1. 2 times 2 plus 1 times 3. 2 times negative 5 plus 1 times 1. So you get 10 plus 18 is 28. You get negative 25 plus 6 is negative 19. You get 4 plus 3 is 7. And you get negative 10 plus 1 is negative 9. And that's your answer. All right, this one looks a little different, but check your dimensions. We have a 2 by 3. We have a 3 by 1, so yes, you can do it. It is a 2 by 1. So you're going to say 0 times 2 plus 1 times 2 plus 1 times 2, because it's row 1 for row 2 times column 1. You're going to say 1 times 2 plus 1 times 2 plus 0 times 2. So your answer is going to be 0 plus 2 plus 2, which is 4, and 2 plus 2 plus 0, which is also 4. So 4 is your answer. Looking at the next one, we have a 3 by 1. We have a 2 by 1. Your 1 and your 2 are not the same. You cannot do this. Remember, your inside numbers must be the same. So you write can't, and you go to the next page. All right, they want us to find the value of each determinant. Remember, you multiply minus you multiply. So it's like -5 times -6 minus 8 times 2, which would be 30, minus 16, and so your actual answer is 14. So -1 times -2 minus 5 times -3, so you have 2. This becomes plus 15. 17 is your answer. It gets a little more confusing when you have a 3 by 3. You're going to take 2 times the determinant of 2, -1, 3, -2, minus, you're going to say -1 times the determinant of 3, -1, 2, -2, plus, you're going to say 1 times the determinant of 3, 2, 2, 3. So this becomes 2 times -4 minus -3, so we have a -1. Minus a negative becomes 1 plus 1 times -6 minus -4. No, -6 minus -2, which is -4. Plus 1 times, this would be 9 minus 4, which is 5. So this becomes -2 minus 4 plus 5. So you end up with -1 for your answer. Okay, so now we're going to use Kramer's rule. Remember, we have A, B, C, and D. This is E, and this is F. You should have Kramer's rule written on a note card. You are welcome to use the note card on the review and on the exam. So using your Kramer's rule, you're going to start by finding X, which is EBFD over ABCD. So X is equal to, and your EBFD is going to be 2, 1, 3, -1. Over your ABCD is 3, 1, 2, -1. So then you're going to say -2 minus 3, and you're going to get -5. Over, you're going to say -3 minus 2, and you're going to get -5 again. So X is equal to 1. So X equals 1 as part of your answer. I'm going to change colors. And so then to do Y, your formula is AECF. So that's going to be 3, 2, 2, 3 over, and it's still going to be ABCD on the bottom, so we know that that is -5. So on the top, you're going to say, if I could read my writing, I believe that's going to be 9 minus 4, so I've got 5 over -5. And so Y is equal to -1, because 5 divided by -5 is -1. So doing the same thing here, make sure you know your A, B, C, D, E, F. And so for X, on the top, you're going to be doing EBFD. So -1, -2, 3, 1. On the bottom, you're going to do ABCD, 1, -2, 2, 1. So -1 minus -6, and so that is going to be a 5 on top. and then 1 minus negative 4, and so that is going to be a 5 on the bottom, which is 1. So x equals 1 is part of your answer. So now I will change colors, and when we do y equal, your top is going to become AECF, so it would be 1, negative 1, 2, 3, and it is still over 5. So you have 3 minus negative 2, and so that would be 5, still over 5. So y is equal to 1 as well. You will be allowed to use your note card with your formula on it. I encourage you to make a note card if you haven't already done so. Find your note card, bring it on test day. So moving to the next page, it wants to determine whether each pair of matrices are inverses or not. Remember that if they are inverses, when you multiply them together, you will get the identity matrix, which is for a 2 by 2, it would be 1, 0, 0, 1. So you're going to have to do row 1 times column 1, row 1 times column 2, etc. So negative 2 times 2 plus 5 times 1, negative 2 times negative 5 plus 5 times negative 2, negative 1 times 2 plus 2 times 1, negative 1 times negative 5 plus 2 times negative 2. So you get negative 4 plus 5, which is indeed 1. You get negative 10. No, wait, let's see. That's positive 10 plus negative 10, which is 0. Negative 2 plus 2, which is 0. And 5 plus negative 4, which is indeed 1. So yes, these are inverse because when I multiplied them together, I got 1, 0, 0, 1, your identity matrix. Okay, so now on the next one, it's telling us find the inverse. And the way you find the inverse also uses a formula. Once again, you can have this formula on a note card. I encourage you to find the note card, add this to it if you need to, whatever. The first thing you're going to do is you're going to take 1 over, and it's AD minus BC. And so you're going to say negative 2 times 0 minus 6 times negative 4. So 0 plus 24. So it's 1 over 24 times, and you have D, negative B, negative CA. So your D and your A swap spots, and your B and your C change signs. So this is going to become 0, 4, negative 6, negative 2. So then you actually multiply, and 1 over 24 times 0 is 0, and 1 over 24 times 4 is 0.17. 1 over 24 times negative 6 is negative 0.25, and 1 over 24 times negative 2 is negative 0.08, and that would be your inverse. If you prefer to do it using fractions, you would have 0, 1/6, negative 1/4, and negative 1/12. I will take either way, okay? I don't care if you use decimals or fractions. So that's your inverse. All right, so I'll change colors, and we're going to do the same thing here. So you start with 1 over, and it's AD minus BC. And so you have 0 minus 49, so you have a negative 49 on the bottom there. And it's going to be times D, negative B, negative CA. So it's going to be 0, 7, 7, 0. And you end up with 0, negative 1/7, negative 1/7, and 0. Or if you prefer to do it with decimals, it's 0, 0.14, 0.14, and 0. And I'm being a little confusing here. I wasn't putting my brackets right. I apologize. Should look something like that. All right, going to the next page.